Hello and welcome to this tutorial here about a meteor strike over a big ocean element with splashes, foam, whitewater, particle elements, waves and all those fancy stuff that you need to make a large scale impact sequence. So here's a pretty early example on how the narrowband fluid solver technique was used inside this Houdini simulation, and you can see how certain areas get affected by the impact of our meteors, and this pretty much is what makes narrowband so powerful. It really only calculates those areas that are necessary for your simulation, and therefore the narrowband technique is pretty much highly recommended for high scale fluid simulations like you can see here in this example. So with different settings you get different results, and here we have some additional elements like the whitewater foam and the splash elements that you can see here flying away from this heavy impact, and all those different specific things that make up the simulations are set up here in the scene file. So before starting with the scene introduction, I assume that you have a basic understanding of Houdini, how to set up the nodes, the cameras, the light, how to cache out files, and how to read files from your hard disk. Otherwise, it would make things a bit complicated, because this is not a fairly basic tutorial, it's more an intermediate one. Also, it's only a tutorial to show you how you can use the scene for your own needs, because it's available for purchase very soon. So to begin with, we have here our meteor element. You can add in whatever you want. Like I mentioned before, you can use your crashing spaceships or your moon, whatever you want to splash into the ocean. And the elements of the creation here are alembics. You can use your own, and what's happening under the hood is that mostly for flip fluid collisions you make a VDB out of your incoming objects. In that case it's happening here in the collision source under the volume tab, and it's creating a voxel out of our geometry, a stored database of volume information. So this database, volume database representation, is later on used for our collision in the narrowband node tree. So we have an ocean here where we define the space where our collision is happening. It's a fairly high flat tank with a size of 1600, 1500 and 2000 units. And to make the needed elements for our narrowband simulation, we have here our surface and particle objects. And the ocean, that is the foreground element, pretty much starts mostly with a grid where you define the resolution. The resolution should be pretty high in terms of detail and the wave visibility. and it's later on then fed into an ocean evaluate node. To make this look like it's looking, you should always turn on deform input geometry, create the cusp attribute, and visualize the cusp. Otherwise you get a gray background on your geometry, and with this attribute ramp you can dial in your own pre-visualization colors to make sure it has the right feeling and the right look. So the ocean spectrum, which is pretty much creating the size of our waves and instances, goes into the second input of the ocean evaluate node, and make sure you save the spectra of the ocean spectrum to disk, because it's pretty much later on used in the texture map for the ocean texture. So let's dive into the .NetFluidsFX node here, where the flipsolver is at home, and you can see that the flip object is using those surface points from our ocean surface that I was discussing in the beginning. And here we have the Meteor, which is using the proxy volume of our volume representation, and the real magic is happening here in the flipsolver. And I'm using a velocity transfer of the swirly epic, and you can see that the volume limits correspond to the ocean source from the ocean surface. In the narrowband, you can see that the bandwidth is enabled to 3, and we have here also ID attribute add, so every particle that is generated gets a separate ID, so you can later on address those IDs and make changes to your simulation afterwards. And we have here our particle motion. We have droplet detection set to 3 and density 2. Vorticity is also something that adds realism to your simulation. I will not go in depth of all those settings, what vorticity and droplet creation is. Mostly you get infos about the object when you hover over the name here. And to cache everything to disk, you should keep in mind that the cache sizes of the elements can become fairly high. So before you make any decision to buy this scene, please make sure that you have an appropriate disk space available. This is something that has Houdini mostly in common, that the cache files per frame can go up pretty high, and but it's also easy to get external hard disk drives for a good price. And to load in our fields created, we have here the DOP import field. You can see it's pointing to the DOP network of our FluidFX, and the DOP node is our flip object. And we can use a preset here. In our case, we use the flip fluid preset to import the different fields. In our case, we have 3: the geometry, the surface, and the velocity. Velocity is mostly also needed when you want to render with motion blur afterwards. And I'm using a fluid compress node, and fluid compress is when you can see this little icon here. It's compressing our incoming fluid to the areas where it's actually only needed. So to show you an example, you can see that. So here you can see how the fluid compress node is pretty much compressing only the areas that are necessary in the simulation, and it's making life so much easier when it comes to high amount of cache files. Don't forget, when you use a fluid compress node, to unpack those little boxes to get your points back. So this cache is then fed into a particle fluid surface, which is doing the meshing for us. So under the hood it has a lot of erosion and meshing functions. So the particle fluid surface, it's meshing our points together, and you can see here how our 3 meteors are creating those impact craters. You can look inside and you can play with all the settings here to make the look of your meshing looking nice. It's pretty much using erode and dilate to make the appearance like you need it in your scene. And what would be the fluid simulation without a whitewater simulation? For all who don't know what whitewater is, whitewater is a addition of several elements that appear also in real nature when collision is happening in water, in a lake, in a river, in an ocean. So it's containing tiny, big, medium, small bubbles. It has foam and spray elements that are combining to this whitewater term of the whitewater element. And this is also simulated here in our fancy scene file. For that we have here the whitewater source, and the source is also cached out to disk. And as you can see in the whitewater source, we have the emission, and we also have vorticity, and we can limit the whitewater emission by depth, and we can set speed range when we want whitewater only happening at certain areas. It's an own chapter in Houdini, the whitewater, but to give a short overview, you can see that it's also used here in the scene, and I show you how the effect is looking in a flipbook. 1 second. So here you can see all those white and blue elements, the ones that strike away and that fly away, make up the whitewater. As nobody really has seen a real impact of a meteor in an ocean or in a bigger water environment, we only can refer to like atomic bomb tests in the sea, and everybody who's looking on YouTube on those underwater and on those over the water surface tests, you can see that there is a heavy amount of not only the splash, but here the white water and the foam and the spray being created. And this is what I try to mimic also in this simulation. And this is what makes whitewater such a interesting element for fluid simulations. It's just adding a new level of realism to different kind of simulations done in Houdini, especially when it comes to rivers or to waterfalls and all the things. So the whitewater solver itself is using the impact static object, in our case our Meteor, and it's using the solver and the whitewater object parallel actually to our flip fluid solver that has also the flip object and the flip solver, and you wire in your different elements also in your node tree. If you want to explore the whitewater solver in Houdini, you can refer to the shelf tools here, which has an own whitewater creation tab, and there's also a lot of documentation material on Houdini's website. So it's a lot of fun playing with those values, and you can see here how the whitewater is created in the certain areas. And keep in mind, this is only a point of possibility you can achieve when you use your own elements, like your own objects and your own water depth. You can achieve pretty different results, and having fun playing around with the scene. And last but not least, we have the additional ocean spray here. This is on top of our wave layer, creating a stormy and vast sea behavior. And this is set up also, as you can see here, it's using different ocean foam approaches. You can add collision into it. This is also covered here. Our DAP network to create the spray, and you can point in different wind values to make it more calm or more hectic, chaotic, however you want to have your ocean look like. And it's also cached to disk, and using some different VEX functions here to make random point colors and behaviors. And last but not least, our lights here. There's a geometry light linked to our Meteor that is making the light shining through the water from above, and some environment and skylights. And here you can see the volume light shining through the water and creating this red like heat and temperature amount of radiation. And we have the spray on top of the ocean and the actual ocean itself. And I would like to see what you would come up with, different ideas of how to, when you use the scene. And I hope you learned something, and if you need some feedback on your scene or have questions about the scene, just write me in the comments. I will paste the link fairly soon where you can get the scene file, and wish all of you a nice Christmas time, and stay safe, and goodbye.